Most professionals are trapped in a constant ping-pong match with chat models, typing a prompt, waiting, copy and pasting data. In this complete masterclass, we're moving to the next stage, using Codex to build a local AI operating system that turns your manual workflows into self-running agents. The value of artificial intelligence lies not in the technology itself, but in how you implement it within your business operations. Right now, the entire landscape is shifting from simple chat windows to goal-driven execution. When you use a standard chat model, your process is strictly a question to answer. You ask a question, the AI replies, then you have to do the manual labor of execution. An AI agent completely flips this dynamic by moving from goal to result. You provide a clear objective, and the agent plans the task, executes the steps, communicates with your tools, and delivers the final business outcome. People who understand how to deploy these systems are becoming 10 to 20 times more productive than their competition. When you stack that operational leverage over days, weeks, and months, you unlock an entirely new level of business performance. Today, I'm going to teach you how to do it. We'll build a complete local AI operating system from scratch using Codex as our primary agent harness. Once you understand these foundational mechanics, you'll be able to structure autonomous departments to scale your execution and eliminate repetitive bottlenecks for good. To build a system that works for you, you must first understand the 4 core components that make up any functional AI agent. These are the large language model brain, the autonomous execution loop, the connected tools, and the structured context. The LLM acts as the central processor, and what turns a model into an agent is the autonomous loop. Instead of stopping after a single response, an agent runs on a continuous loop of observing, thinking, and acting. When you give an agent a goal, it immediately observes its environment to check available files and data. It then thinks about the optimal next step, takes an action, and feeds the result back into the observation step. Okay, now let's ground this abstract concept with a real business scenario. If you ask a blank agent to build a minimalist portfolio website, the agent enters the loop. First, it observes that it has no data on this person. It thinks, I need to know who this individual is before I can design a site for their portfolio. It acts by creating a research process connected to a search engine to scrape the web. The research results are fed back into the observation stage. Now, the agent thinks, I have the biography and background information, so the next logical step is to draft a site layout plan. It writes the plan, reviews it, writes the code, boots up a local testing server, and takes a screenshot of the page to verify that the layout looks correct. If there are any issues, then it'll analyze the situation and come up with solutions. The agent continues this self-correcting loop entirely on its own until it fulfills the specific requirements you set in your original objective. The desktop application that facilitates this autonomous loop is known as an agent harness. Codex is exactly that, a robust frame that anchors the loop, manages your local files, and handles your data integrations cleanly without clunky cloud workarounds. The true future-proof AI stack doesn't live inside a busy web interface or a cloud repository you can't control. It runs off simple, clean Markdown files stored locally on your computer. Markdown is the most efficient format for an agent to digest, analyze, and modify without introducing processing errors. When you build a local AI operating system, you must approach it exactly like onboarding a real human employee. If you hired a new executive assistant today, you wouldn't expect them to perform well if you just threw them into an empty office without explaining your business model, your core systems, or your communication guidelines. You have to train them and give them a structured environment to work in, right? Let's begin by establishing a clear directory system on our local hard drive. Create a master folder named after your company, and inside it, create dedicated subfolders for each distinct department within your business. You'll have a folder for your executive assistant, one for your head of marketing, and one for your accountant. Isolating your departments into local folders ensures that the context remains perfectly organized. Once your folders are created, we open the Codex desktop app, click Project, select Use an existing folder, and then choose the corresponding folder for each department. This connects Codex to our workspace. Today, we're focusing on building out the Executive Assistant folder to automate your manual daily operations and reclaim at least 2 hours of deep work every single day. The era of prompt engineering is officially dead. High-performing employees do not spend their days tweaking complex multi-page prompts to get a decent output. We've entered the era of context engineering. The goal is to build a flawless contextual system so that your daily operational prompts can be completely simple, yet return useful results. To achieve this, we introduced the first must-have file into our local Executive Assistant folder, a system instruction file named agents.md. Inside Codex, this acts as your permanent custom instructions. This file is an always-on, non-negotiable set of rules that the agent loads into its brain during the observation step before it processes any task. Inside this file, you outline the explicit role of the assistant. Then you provide detailed background information about your business, your ideal customer avatar, your operational tech stack, and your communication preferences. Let's look at how this changes your workflow. If you open a completely fresh session in an empty folder inside Codex and type, "Write a cold email," the AI will stall. It'll ask you what you sell, who your target audience is, and what tone you prefer. Or worse, it'll make random assumptions and give you rubbish that you can't use. But when you place a properly structured agents.md file inside your workspace, Codex automatically reads that file the second you initiate a task. You can type the exact same brief phrase, "Write a cold email," and the system instantly references your business context, identifies your core product offering, it targets your specific buyer persona, it adopts your exact brand voice, and it creates a highly converting asset on the very first try. Okay, now that we've anchored our agent with our core business context, we run into a second operational bottleneck. Standard AI sessions have no long-term memory. If you correct an assistant during a chat and say, "Never sign my emails with formal corporate phrasing, keep it casual," the AI will apologize and adjust it in that specific conversation. But tomorrow morning, when you start a new session, that preference is completely gone. The agent reverts back to its default programming, and you're stuck babysitting the machine all over again. We solve this problem by installing a dynamic, self-improving memory loop using a second markdown file called memory.md. We don't rely on the hidden cloud memory features built into a commercial chat platform because they mix context from unrelated conversations that show up to us as output that's also unrelated and not helpful. Instead, we want an isolated, audit-ready memory file right inside our department folder. To make this memory system functional, we append a specific instruction to the top of our master agents.md file inside Codex. We instruct the agent to read memory.md at the start of every session to understand what it has learned over time. And the key is this one important instruction. Whenever the user corrects your behavior, updates a preference, or teaches you something new, you must immediately rewrite and update the relevant section inside memory.md in real time. So now, if you run a session in Codex and tell the agent that your favorite color is lavender, or that you strictly communicate with clients via email instead of Slack, Codex executes the task and then immediately writes that preference into your local file. So as you work with this assistant day in and day out, this file automatically accumulates the new adjustments. The system becomes sharper, the operational guidelines become tighter, and over weeks and months, the rate of execution errors drops to near zero. A standard employee relies on standard operating procedures, or SOPs, to execute repeatable business workflows with absolute consistency. In Codex, we translate our business SOPs into dedicated architecture called skills. A skill is a structured markdown file that teaches your agent exactly how to execute a complex multi-step process perfectly every single time without clogging up your master context files. Codex features a dedicated tab for managing skills visually, making it incredibly simple to organize your business workflows. There are two primary ways to manufacture a new skill for your agent inside the platform. The first method is concept-driven. If you have a comprehensive training manual, a video transcript, or a specialized framework for creating viral hooks, you can upload that raw data directly into Codex. You tell the system, analyze this training data, and package it into a permanent execution skill. Codex will automatically build a structured markdown file inside its skills directory, complete with reference formulas and execution boundaries. The second method is workflow-driven. When you manually guide your agent through a complex business process for the first time, such as pulling data, formatting an important client proposal, and structuring the pricing breakdown, you don't want to lose that workflow. So once you achieve the perfect final output inside Codex, you simply issue a clear command. Create a permanent skill for the exact process we just executed. Codex reverse engineers its own successful steps and saves them as an off-the-shelf workflow file. For instance, you can build a referral skill that safely stores the contact details, email addresses, and service offerings of your trusted vendors. The next time you need to connect a prospect with a partner, you don't need to look up emails or write an introduction from scratch. You simply tell Codex to call up that specific referral skill, and the system executes a template exactly as you instructed using the correct data. Context and memory make your agent smart. And now, connecting your tools is what grants it the power to execute real business workflows. We achieve this deep software integration using an open source standard known as the Model Context Protocol, or MCP. Before the introduction of MCPs, getting a large language model to interact with external software required custom, expensive API developments. Why? Because the model speaks English, your project management tool speaks one code language, and your database speaks another. The MCP acts as a universal standardized translator that sits directly between your AI agent and your software stack. It allows the agent to read and write data across your everyday applications safely and instantaneously using standard English commands. Inside Codex, you can navigate to the Settings panel and manage your connected tools visually. By linking your tools through an MCP, you create a unified environment where you no longer need to manually log into individual applications. You can open Codex, stay inside one clean workspace, and manage your entire digital operation. Now let's look at a compound workflow. You receive an email from a qualified sales prospect. Instead of spending 30 minutes jumping between tabs, you issue one single goal to Codex. You say, summarize my inbox, look up my meeting notes for this prospect inside my transcription tool, generate a custom proposal checkout link using my payment processor, map out a new client onboarding board in my project management database, and draft a tailored follow-up response inside my email provider. Because Codex loops through its tasks and has direct access to your tools via an MCP, it executes that entire multi-app sequence in a matter of seconds. It pulls the meeting notes, it creates the secure checkout link, it logs the project in a database, and it presents an email draft sitting in your outbox ready for your final approval. As you begin to scale your local AI operating system across multiple departments in Codex, you must understand how to manage and optimize your architecture for long-term performance. One of the critical concepts is the distinction between global assets and project-level assets. Global assets are context files, tool connections, and skills that you want available across every single chat session in your company. For example, a text truncation skill that shortens long copy without losing the core meaning is universally useful. You save that at the global level of Codex, so your marketing agent, your sales agent, and your executive assistant can all access it instantly. Conversely, project-level assets must remain strictly locked inside their specific department folders. You don't want your personal executive assistant skills cluttering the context window of your marketing agent because this wastes processing capacity and introduces data drift. Additionally, you have to maintain strict hygiene with your markdown files. A core operational best practice is to keep your agents.md and memory.md files focused and concise, ideally under 200 lines of text. If a memory file becomes bloated with minor, insignificant corrections over a year of continuous use, you should open the file and manually clean out the outdated data to ensure Codex remains fast and precise. And finally, always think about security scoping. When configuring your tool permissions inside Codex for high-risk platforms like ad accounts or financial backends, prioritize read-only access where appropriate. This guarantees that your automated loops remain secure while executing business tasks. All right, we've covered the complete structural blueprint for transitioning from fragile AI prompting to building a robust local AI operating system. True operational leverage is built by stacking these simple, repeatable components together. By combining targeted context files, self-improving memory loops, structured business skills, and universal tool integrations via MCPs inside Codex, we've effectively built a reliable assistant that works exclusively for your business. Thanks for watching, and see you in the next implementation guide.